Alright, welcome back. In this video I'm going to describe some of the rules and shortcuts for taking antiderivatives. The first shortcut is for taking the antiderivative of a power function, x raised to some constant power. What you will always get when you take the derivative of an expression like this is 1 over that power plus 1 multiplied by x to that power plus 1 plus the arbitrary constant of integration. So some examples of this formula being used. I'm going to do something similar to the derivative step that we often work with constants. When we take the derivative of a constant multiplied by a function, we can take that constant, the one that's multiplied or divided, and bring it out front. So I'm going to do that here. I'm going to say it's 5 multiplied by the antiderivative of x to the power of 9. Now we're asking, what do you take the derivative of to get x to the power of 9? This anti-power rule tells us that we're going to get 1 over 10. So we divide, we have 1 over the old power plus 1 times x to the power of the old power plus 1 plus c. We can simplify. 5 over 10 is 1/2, so I have 1/2 x to the power of 10 plus 5 times c. And then if c is an arbitrary constant, so is 5c. 1/2 x to the power of 10 plus c. I just changed the color of it, but it's still arbitrary constant. So if c is an arbitrary constant, then so is 5c. So I just got rid of the 5. It's still arbitrary. And from here on, I won't show that anymore. I'll just say plus c. If there's a constant in front of the integral, I'll just ignore it. As far as that constant part is concerned, I'll just call it a plus c. Okay, next example. How are we supposed to use the power rule here, or the anti-power rule? How are we supposed to do that when there's no power? Well, the same thing we do when there's a derivative. We convert, or a derivative of a square root function. We convert the root into a power. So we have the antiderivative of x to the power of 1/2 dx. Now, to not confuse ourselves, I'm not going to try to do this brute force. I'm not going to try and think, backwards. What do I take the derivative of to get this? I'm just going to use the anti-power rule. So the anti-power rule says I'm going to have 1 over the old power plus 1 multiplied by x raised to the old power plus 1 and a plus c. And then we can simplify. 1/2 plus 1 make common denominators. 1 over 2 plus 2 over 2, we get 1 over 3 over 2 multiplied by x to the power of 3 over 2 plus c. And then if you divide by a fraction, so 1 over 3 over 2, that's the same as multiplying by the reciprocal. So it's 2/3 x. I'm going to scrunch it in a little bit better than that. 2/3 x to the 3 over 2 plus c. Now that last one here we just did may make you uncomfortable because of all the fraction work. And you may be worried that if you're doing this on your own, that you screwed it up. You can check if you screwed it up or not by taking its derivative. So if you take the derivative of this, the 3 over 2 comes down, multiplies by the 2/3. So the 2 on top cancels the 2 on the bottom. 3 on top cancels the 3 on the bottom. We have 1 multiplied by x to the power of 3 over 2 subtract 1. So 3 over 2 minus 2 over 2, which is 1 over 2. So just x to the 1/2, which is root x, plus the derivative of c, so plus 0. Hey, we got our function back. We got the thing that's inside the integral back, the root x. Last one, what do? Well, I'm going to do 2 steps in one. I'm going to take the 3 and put it out front. And I'm going to convert x to the 6th in the denominator into an x to the negative 6 in the numerator using the classic exponent notation for reciprocal exponents. Right now, I'm not going to try to do this by brute force. I'm just going to use a formula. The formula's right there. It's 3 multiplied by 1 over the old power, negative 6, plus 1, times x to the negative 6 plus 1 plus c. And then we can clean this up. We have 3 divided by negative 5 times x to the power of negative 5 plus c, which is, I'll write it in a better looking way. Everyone gets weirded out when the minus sign is down in the denominator. Negative 3 over 5, x to the negative 5 plus c. And then take the derivative to check. The negative 5 will come down, so the negative and the negative will cancel. 5 on top cancel 5 on the bottom. The 3 will survive. We'll have x raised to 1 lower power, so negative 5 subtract 1, negative 6. Hey, we get our original back. We get 3x to the power negative 3x to the negative 6 back. Some more complicated ones. So the trick in mathematics, and more than just mathematics, in many different types of problem solving, is to take the problem that you have and transform it into a problem that you know how to solve. So how do I take this question and rewrite it so that I can use this approach to find the answer? Because if I don't do that, if I try to invent a new method, what's the anti-product rule for this? Because if I took the derivative of this, I need a product rule. So what's the anti-product rule? And that's actually something we'll talk about, but we don't have it, and it turns out that we don't need it. What we can do is we can first simplify the function. So I'm going to write down the answer, f of x is equal to the integral of square root of x, so x to the power 1/2 times 6 plus 5x. I'm going to put the dx there just to indicate that I'm taking the antiderivative with respect to the x variable. I need to do that. It's not something you can skip. Next, I'm going to expand. And that's the key. What's the magic step for something like this? Is to expand the expression and make two expressions. So we'll have 6 times the antiderivative of x to the 1/2. I'll do it in 2 steps. I'll put some more steps into this. So integral of 6 x to the power 1/2 plus 5. Now, when we multiply x times x to the 1/2, it's x to the 1 times x to the 1/2. So we'll have the powers adding. 1 plus 1/2, we'll have 3 over 2. I'll write that step down, actually. Why not? It's an important step. So x to the 1/2 times x to the 1, or times x, is x to the 1/2 plus 1, which is x to the power of 3 over 2. Okay, now I'm going to use a property of integration that I haven't told you about yet. So the property is that the integral of f of x plus g of x is equal to the separate integral of f of x plus a separate integral of g of x. This should look super familiar. We've been using this type of rule since you started taking derivatives. This is similar to d by dx of f plus g is equal to f prime of x plus g prime of x. The derivative of a sum is the sum of the derivatives. The antiderivative of the sum is the sum of the antiderivatives. So we're just by analogy using that rule here. Okay, so I'm going to split this up into two integrals, 6 times the antiderivative of x to the power 1/2 with respect to x plus 5 times the antiderivative of x to the 3/2 with respect to x. And now I'm going to use the anti-power rule. So 6 times 3/2, no, not 3/2, 2/3. I'll do it in two steps. 1 over 3/2 times x to the power 3/2. So I added 1 to the power and then divide by the new power. Plus c. So I'm just going to skip this. Oh, did I put a plus c here? Yes, okay. I'm going to skip the step again of putting 6 times c is just a different color, c. And then plus, now I have another antiderivative, 5, and then we're going to add 1 to the power. So we'll have 3/2 plus 1, which is 5/2. So 1 over 5/2 times x to the 5/2 plus, well, I'll use a different color c here since it's a different constant of integration, right? I have two integrals. I have one constant from one, another constant from the other one. And I'll make that one different too. Use lots of colors. Now I'm going to simplify. So we have 6 multiplied by 2/3 x to the 3/2 plus 5 multiplied by 2/5 times x to the 5/2. And then we have 2 plus c's that I'll tack on at the end. 6 times 2/3 will be 4 x to the 3/2 plus 2 x to the 5/2. And then I'm going to put one big honkin' plus c. No one says big honkin' anymore. Why not? So I just combine both of those plus c's into one bigger arbitrary constant. And from here on in, I'll skip showing that step. The two constants came out, I'll just immediately smush them into one constant. Now to check, what we would have to do is we'd take the derivative, simplify, then factor out root x, and hope that we recover the original expression, and I leave that as an optional homework piece for you to do. Okay. Now, again, the big philosophy. What are we doing? We're trying to recycle strategies that we've found to already work. So we've already found that the anti-product rule works. Anti-power rule works. Can I reform this question in order to use that anti-power rule? And the answer is yes. I'm going to just divide. And the rule I'm going to use is that a plus b plus c all over d. I can write that as a over d plus b over d plus c over d. Just going to split the fraction up into 3 fractions. So this is an integral of 4x to the 7 over x to the 3 plus 3x to the 5 over x to the 3 plus 2x over x to the power 3. And then I'm going to split that up into 3 separate integrals, just taking this f plus g rule and having an f plus g plus h rule. The sum of 3 things integrated is going to be the sum of 3 separate integrals. So we have 4 times the antiderivative of the power subtract, x to the power of 7 minus 3, so 4, with respect to x, plus 3, integral x to the 5 over x to the 3, the power subtract, x to the power of 2. And the last one, we have x to the power of 1 over x to the power of 3, so it'll be x to the power of negative 2. And then use the anti-power rule on each piece. So we'll have 4 times 1 over 5 x to the power of 5 plus 3 times 1 over 3 x to the power of 3 plus 2 times 1 over negative 1 times x to the power of negative 1. And then the first one gave me a c, the second one gave me a c, the third one gave me a c. I'm going to put them all together as one big plus c and then simplify. So 4 over 5 x to the 5 plus x to the 3 minus 2x to the power of negative 1 plus c would be our answer. Don't do funny stuff. Don't do weird stuff. Don't try to make common denominators. Don't try to factor it. Don't try to simplify it. Just don't do any of that. Leave it alone. Okay. Each one of these has been the same game. And what has that game been? Use the one rule that we have. The old expression, when you have a hammer, everything looks like a nail. Sadly, all we have right now is a hammer. And if what we are given is not a nail, there's nothing that we can do. So I've cooked problems that can be manipulated so that we can use that one tool that we have. But don't fall under the illusion that every problem will have this pattern. This is just kind of a warm-up for antiderivatives. All right, so big picture. How do we make this look like each of those pieces? Antiderivative of x to the 4, antiderivative of x to the 2, antiderivative of x to the negative 2. Well, we're just going to FOIL. So antiderivative of 2 times 2, 4, and then 2 times negative x, negative 2x, plus inside times inside, last times last. Those two cross terms are going to cancel each other. So we have the antiderivative of 4 with respect to x minus the antiderivative of x squared with respect to x. Okay, now this is new. We haven't had this yet. d by dx of what equals 4? What do you take the derivative of to get 4? And the answer is 4x plus c. So the antiderivative of 4 is 4x plus c. But I'm going to tack that plus c on at the end for both the pieces. The first piece, or rather the second piece, antiderivative of x squared, using the anti-power rule, it's 1 over 3x to the power of 3. And the plus c is too far away, so I'll bring it closer. They can be together. That's our answer. Let's see. Anything worth mentioning about this? I guess a question is, what would have happened if you factored the 4 out front? Well, if you factor a 4 out front, you're left with a 1. Factoring means division. Like when you factor, let's say the 3 out of the second term there, you're dividing by 3. The remainder is what's appearing in front. The remainder happens to be 1, so we don't write it down. If I factor a 4 out, there's going to be a 1 that's there. 1 multiplied by dx, and the antiderivative of 1 is just x. So we'll have 4 times x. That's just a different way to write it, different way to think about it. Okay, this one's for homework. I want you to do this on your own. Follow the same strategies that we've already seen, and then compare to what we get inside the notes. So I'll show you next a different type of question. It's related, similar. We're told that the derivative of the mystery function is 3x squared. And the mystery function evaluated at 1 is equal to 5. And I'm going to write that down, because having an understanding of the mathematics in words is extremely helpful. There's different ways of understanding math. There's understanding math with equations, there's understanding math with words, and there's understanding math with pictures, with graphs, with diagrams. And to understand math in the most honest way, you should know all three. You should be able to describe it in words, work with the equations, and draw a picture of what it means. Drawing a picture of what this question means is going to take a little bit more time. We're working towards it. You're going to have we'll eventually have a geometric understanding of what this question is saying, but for now we'll just have to wait. Okay, so I'm going to write down that I'm going to write down what the words are. The derivative of the mystery function is 3x squared. Okay, and the second part is that the value of the mystery function, so the y value or the output, at x equals 1, so that's the things being plugged in, is 5. So the height of the function at x coordinate of 1 is 5. Or another way to say this is that the function passes through the point 1, 5. So for our solution, f of x is the integral of 3x squared. That's part of it. That's part of what we'll have to do. So we'll take the antiderivative. We get 3 times antiderivative of x squared, 1 over 3, x to the power of 3, plus c. So x to the power of 3 plus c. That's f of x. This is where the second piece of information comes in. Now, we're going to use the fact f of 1 is equal to 5 to find the value of c, this constant that is no longer going to be arbitrary. We're going to pin its value down using this extra piece of information. So f of 1 is equal to 1 to the power of 3 plus c. F of 1 gets replaced with 5. 5 is equal to 1 times 1 times 1 plus c. And then that means that c is equal to 5 minus 1, which is 4. So thus, our function f of x is x to the power of 3 plus 4. Homework. Check f prime of x is equal to 3x squared and f of 1 is equal to 5. Check both of these features or properties. If this solution, this proposed solution, fails to satisfy either of those two requirements, then it's actually not a solution at all. It's wrong. That process we just went through is a process sometimes called solving a differential equation. It's a very simple type of differential equation. That's a type of initial value problem. The easiest type. We'll look at harder types later. The ingredients of the initial value problem are the derivative of the mystery function, so you're told what f prime is, and you're told what some value of the mystery function is at some point. And then those two ingredients are enough to find what the mystery function is. The steps to solve a problem like this are very consistent. The first step is you will always take an antiderivative first. You cannot forget the plus c or everything gets screwed up. Then you use the information about the value of the function at that point. So evaluate the antiderivative at x equals a, replace f of a with b, and then rearrange, solve for c, and then state your solution. your solution at the end will not have c in it anymore. The value will be pinned down using that initial value, using f of a is equal to b. Okay, here's a more advanced version. We're asked to find the original function, f of x. This time, we're not given the derivative of the mystery function, we're given the second derivative of the mystery function, and we're given two pieces of information. So I'm going to write down the steps here. Step 1 will be, if I take the antiderivative of the second derivative, what do you think we're going to get? We're not going to get the original function. We're undoing one of those two derivatives. There's still going to be another derivative left. So we're first going to find f prime of x by evaluating, or not evaluating, by integral of f double prime of x dx and using f prime of -1 is equal to 5 to find the constant that comes out. So let's do that, and then you might be able to guess what step 2 is. So f prime of x integral of 12x with respect to x plus the integral of 3x squared with respect to x. So just immediately split it into two antiderivatives, which will be 12 times 1/2 x to the power of 2 plus 3 times 1/3 x to the power of 3 using the anti-power rule for both, plus a constant of integration. Simplify 12 over 2, 6 x squared plus x cubed plus c. Now I have to use the f prime information because that's what I have. So f prime of -1 is equal to 6 times -1 squared plus -1 cubed plus c. So I have 5 is equal to 6 minus 1 plus c. This tells us that 5 is equal to 5 plus c, which means c is equal to 0. So we can write down what f prime of x is. F prime of x is 6x squared plus x cubed. Okay, now step 2. We're going to find f of x by the antiderivative of f prime and using the information about f of 1 is equal to 0, about the value of the function. So if we had 3 derivatives, we would have to do the antiderivative process 3 times, and we would need 3 pieces of information to nail down all the constants that will come out. Okay, so f of x is the antiderivative of 6x squared plus the antiderivative of x cubed. And notice that every time I write down an antiderivative, I'm constantly, without fail, including the dx. And you have to get into that habit. It won't always be dx. Sometimes it'll be something else, and we'll have to track what it is. Okay, so we take the antiderivatives. We get 6 times 1/3 x to the power of 3 plus 1 over 4 x to the power of 4 plus c. And then we can clean this up a little bit, not much. 2 x to the power of 3 plus 1 over 4 x to the power of 4 plus c. Now we'll use our data. We'll plug in f of 1 is equal to 0. So f of 1 is 2 times 1 to the 3 plus 1 over 4 times 1 to the 4 plus c. So we have 0 is equal to 2 plus 1 over 4 plus c, which means c is equal to -8 over 4 minus 1 over 4, making common denominators and subtracting the two which is negative 8 over 4, and the 1 over 4, subtracting those from both sides, and we get minus 9 over 4. So we can make our conclusion, thus f of x is equal to 2x cubed plus 1 over 4 x to the 4 minus 9 over 4. And that is our particular solution. That's the solution given all the information. All right, and here is a test style example. This is super important to be able to do something like this one. We're asked not to find f of x, we're asked to find f of negative 1. So this is a three-step question. Step 1 is we're given f prime, so if we take the antiderivative of f prime, we'll get f of x. F of x is the antiderivative of f prime of x. And use f of 1 is equal to 20 to get c. So let's go ahead and do that. F of x is equal to integral of 12x with respect to x plus integral of 3x squared with respect to x. We'll get 12 times 1/2 x squared plus 3 times 1/3 x cubed plus c. Let's simplify. 6x squared plus x cubed plus c. Now we'll use that piece of information. F of 1 is equal to 20. So f of 1 is 6 times 1 squared plus 1 cubed plus c is equal to 20. So 6 plus 1 plus c is equal to 20. So c is equal to 20 minus 7, which is 13. Thus, f of x is equal to 6x squared plus x cubed plus 13. And we want to find f of negative 1. So 6 times negative 1 squared plus negative 1 cubed plus 13. So 6 minus 1 plus 13, which is 18. We'll continue in the next video.